Okay, so in the first part of this question, we're asked to calculate the number of moles. And to do that, we're going to need to assume that it's an ideal gas, so that it obeys the ideal gas law, PV is equal to nRT. So we can rearrange this and we have N is equal to PV over RT. Now what's a bit tricky here is all the units. Almost none of them are SI units. Okay, so the pressure, we're told that in atmospheres. So to convert that into SI units, we can do 1.20, that's the pressure in atmospheres, times 1.013 times 10 to the 5. That puts it into pascals. The volume is 2.5 litres. So to get from litres to metres cubed, we need to times by 10 to the minus 3. So that's equivalent to dividing by 1,000. We then divide by R, the gas constant, which is 8.314, and times by T, the temperature, but remember that needs to be in kelvins, so we're at 30 degrees C, and then we add 273. Okay, so we solve this one on the calculator, and we get 0.1206. We should probably give it to 3 significant figures, so that's 0.121 moles. Okay, part B then asks us what's the change in entropy. So we're trying to find the change in entropy. And in order to do that, we've shown that the change in entropy of an ideal gas is given by NCV times log of the final temperature over the initial temperature plus NR times log of the final volume over the initial volume. Now, in this case, as it's in a sealed container, the volume is constant. The volume of the container changes very little. So this tells us that we've got log of VF on VI. VF and VI are the same thing, so this is log of 1, which is equal to 0. So this part of the equation here, this is equal to 0. So all we need to do is consider this part of the equation here. Now, we've already calculated what N is, the number of moles. So we need to look at CV. We know that CV is F over 2R. In this case, our gas is nitrogen gas, which is a diatomic gas with nitrogen molecules. It's at around room temperature. So diatomic molecules at room temperature have F is equal to 5. So we've got CV is equal to 5 over 2 times R. And so now we can substitute in the change in entropy is equal to N. So let's keep all our significant figures for now, times CV, which is 5 over 2 times R, which is 8.314, times log. Now the final temperature, that's 45 degrees C over the initial temperature, which was 30 degrees C. Okay, so now we solve this on the calculator and we end up getting 0.121, and the units in this case are joules per Kelvin, and it's truly just a coincidence that these two numbers are the same. It's just that this part of the equation turns out to be 1.00, which was just a fluke.